plank is concentrated at the center. So AB, whose length is 5 meters. So let's draw something to represent the uniform plank AB. This is A, this is B. Then we are told it has a mass of 30 kilogram. Its length is 5 meters. So its mass of 30 grams, because it is uniform, would act at the center. The whole length is 5 meters. So the center of this will be the 2.5 mark. And that is where its weight, total mass, would act. So 30 kilogram. The next question is that a mass of 50 kilogram is at end A. So at end A, we have a mass of 50 kilogram. At the other end, and a mass of 40 kilogram at the end B. So at B, we have 40 kilogram. Now calculate the distance of the pivot from end A if the plank is to remain horizontal. Okay, now one thing you have to understand is that, Julian, is it wrong hand or correct hand?
The correct hand.
Okay.
Sir, please, isn't the weight, the mass at the end A, is it not 55?
Yeah, thank you. It's 55. Thanks for the observation. So 50.
Yes,
I want to change the marker. Okay, so this is 55. Now, we are told it's a uniform beam. Its uniformity means that its total mass or weight would act at the center. What it means is that if we are to pivot it here at the middle, where its mass would actually act, there will be a balance if there is no weight. So if I have a uniform beam and I want to test whether it will balance on a pivot, because this is uniform, I maneuver, look for the middle. This is 50 centimeter rule. So I look for the 25th centimeter mark. And if this is a 9th edge, that is where it must balance. This is a flat board. It's flat. But if this had been a 9th edge, it will balance at the middle. So if there is no weight attached to this, if you want to balance it, because this is uniform, you must place the pivot at the middle, and the total mass or weight of the plank would act at that point, and so it will balance. If you have happened to carry board or log before. You see, whenever you carry a log and then you don't place your head well, it will either turn in front of you or behind you. You naturally adjust it until you've located the center. Then it can be carried in such a way that you can take your hand off and the board will still be on your head. That is the practicality of this situation. So it being uniform means that if you want to balance it, you just place the knife edge at the center. And if there is no mass attached to this, it will balance. Now, if there is a mass, like we have in this case, 40 kilogram here, and then 55 kilogram here, there is no way to balance. Why? The reason is that the distance from this mass to the center is 2.5. The distance from this mass to the pivot is also 2.5. In this case, it means its weight or its mass would produce zero turning effect because there's no perpendicular distance. Please, I hope you are following.
Yes,
Yes, sir.
So this is of no use because it will produce zero turning effect. So equal distances, but because the masses are not the same, if you calculate the turning effect of this, 55 times perpendicular distance, 2.5, it will not be equal to 40 by 2.5. This turning effect will be greater than this. And so the net turning effect will be in this direction. So if you put the pivot here, it won't balance because of the different masses or weights it would exert. Okay, so where do I have to put the pivot so that it will be at rest or there will be a balance? All that I'm saying is that from the point or from the NA, let's assume the pivot is here. The pivot is here. From A. Now this distance, I don't know. So let that be X. So the distance from A is X. Is that okay? So if that is X, then it means that from the pivot to where the 40 kilogram mass would act must be 5 minus X. What about this distance? The perpendicular distance from the pivot to its central mass. What will be the distance there? Yes. What will be the perpendicular distance from the 30 kilogram to the pivot? Anybody? Anybody? Julian, what will be the perpendicular distance from the pivot to its mass or to the mass of the board, 30 kilograms? What will be the perpendicular distance?
The 2.5 minus X.
Exactly. So this is X. The whole of, please, from A to where the 30 kilogram is 2.5. So if this is X, from here to here is X. Then when you subtract X from 2.5, you have this distance. So this is 2.5 minus X. So you take the turning effect. This will give you anti-clockwise. This will give you clockwise. This will also give you clockwise. So sum of clockwise movement must be equal to sum of anti-clockwise movement. So 55 times X must be equal to 30 times 2.5 minus X plus 40 times 5 minus X. So sum of anti-clockwise movement is equated to the sum of clockwise movement. Please, is it understood?
Yes, sir.
Yes, please.
Elizabeth,
Yes, please.
what's the problem?
Please, there's no problem.
Oh, okay. All right, so we solve it. Let's solve for x. So 55x is equal to, now let's divide 2 by 5 to reduce this. So this is 11x is equal to 6 times 2.5 minus 6 times x plus 5 will go this 8 by 5 minus 8 by x. So 11x is equal to, what is 6 times 2.5? 6 times 2.5.
15.
Okay. So 1 6.
No, 15.
All right. So 1 5 minus 6x plus 40 minus 8x. You group like terms. Okay, so this is 14. 14 plus 11. 25x is equal to 55. Therefore, x equals 55 on 25. What is 55 on 25?
2.2.
Okay, so we have x being equal to 2.2 meter. So it means that if you suspend this mass, okay, at the end, to balance, the pivot must be placed 2.2 meter from A, or you can also take it from B. If this is 2.2, then 5 minus 2.2 would give you the pivot's position from B. So that's it. Please, any question before we look at the B, the second question. Now, the second question, it says that if the 55 kilogram mass is moved 0.5 towards the middle of the plank, calculate how far the 40 kilogram mass must be moved if the seesaw is to remain horizontal. Mame, yeah.
Mr. Adia, please, I don't understand why it should be 5 minus x for the 40. I don't understand why it's 5 minus the x.
This one.
Mm-hmm.
Okay, we are looking for turning effect, and turning effect is force times perpendicular distance or mass times perpendicular distance. Okay, so if I'm saying that let the position of the pivot be x from the end A, let that be x from the end A. Let me clear. We know the whole length to be 5. So if the whole length is 5 and you are saying that let this be x, Mamiya, what will be the remaining length from the end B? What will be the remaining length? If this is 5, what will be from here up to B?
5 minus x.
So So 5 minus x will be this distance. Now we are looking at the turning effect produced by all the masses. So if this is B is at a distance, or 40 kilogram is at a distance 5 minus x from the pivot. There's the pivot. What is the perpendicular distance from this mass of the plant? 30 kilogram from the pivot. The whole of this distance is 2.5. So if this is 2.5, and from here, from the 55 kilogram to the pivot, we are saying this is x. Then this will also be 2.5 minus x. Mommy, are you okay?
Yes, please.
So you finish and take the turning effect produced by all of them. And that's equates clockwise turning effect to anti-clockwise turning effect. All right. Then, if the 55 kilogram mass is moved 0.5 meter towards the middle of the plank, calculate how far the 40 kilogram mass must be moved. Now, let's see. So all that we are saying is that we have identified the position of balance, but this time around, we are changing the position of the 55 kilogram, changing it by 0.5 meters towards the center. So it means that from the end to the new position of the mass, this must be 0.5 meters. Now, but the point is that when we manage to get the pivot here, the original position of 55 kilogram was here. So it means the moment we change it, we have to also look at how to change this so that we can find a balance. Don't forget, we can't touch the 30 kilogram one because that is the mass of the uniform plank. And so long as it is uniform, we can't change its position. It will always act at the center. But the moment we change one position of one mass, we must change the other one so that we can get a balance. Or we must change the position of the pivot. But the question is not requiring that we change the position of the pivot. It is asking of changing the 40 kilogram mass, and so that an equilibrium position can be obtained. Please, are we okay? So if this is pushed into it by 0.5, how much do we have to change the 40 kilogram mass so that we have a balance? So I'm also assuming, okay, from this point, from the NB to where the 40 kilogram mass must be, we don't know. So let's represent this distance by y. So if this is y, what will be the perpendicular distance of the 40 kilogram mass from the pivot? If this is y, if we are saying let the position of 40 kilogram from the end be y, what will be the perpendicular distance from the pivot to its new position? This distance I mean, what will be it? Yes.
5 minus y.
Yes. Oh,
5
6 minus y. Oh,
well,
minus
come again.
yeah, 5 minus.
Don't forget, we already have this. This distance of the pivot. We have 2.2, meaning that the remaining end is 5 minus 2.2. And that will be what? What will be 5 minus 2.2?
2.8.
2.8. So if we are saying let the 40 kilogram mass be moved through a distance y, what will be this distance from the 40 kilogram to the pivot? What will be the distance?
2.8 minus y.
Exactly. 2.8 minus y, because this is 2.8 and this is y. Okay, so let's take the turning effect now. The turning effect produced by the 55 kilogram. This will be anti-clockwise, clockwise, and then clockwise. So 55 times, what will be the perpendicular distance? If we move it 0.5 meters towards the center, what will be the perpendicular distance from the 55 to the pivot? Yes. Oh, who is talking?
1.7 meters.
Yes. So
1.7.
so this is
1.7.
1.7. This is 2.2 and this is 0.5. So the remaining distance of this to the pivot is 1.7. So 55 times 1.7 is equal to the turning effect produced by this 30 times what's the perpendicular distance from the 30 to the pivot?
0.3.
0.3. Okay. This is 2.2. 2.2 and this is 2.5. So the remainder is 0.3. This plus 40 kilogram times 2.8 minus y. Of course, let's divide through by 5. 11 times 1.7 is equal to 6 times 0.3 plus 8 times 2.8 y. 11 times 1.7. 11 times 1.7. Oh, aren't you talking? And then this one is, what will be this?
Please, 1.8.
Let's expand this. 8 times 2.8. 8 times 2.8.
22.4 minus 8y.
So group like terms. So 8y is equal to, let's add this one. So minus 18.7. 24.2 minus 18.7.
5.5.
So we have 5.5. So that y is equal to 5.5 divided by 8. What is 5.5 divided by 8?
0.6875.
0.6875 So it means that if we move the 55 kilograms, 0.5 meters towards the pivot or the center, we must also move the 40 kilogram mass by this amount, by 0.6875 meters to still have a balance. This is all. So from the NB, it means we are to move the 40 kilogram by this amount to balance, or we can calculate the distance from the pivot. Okay, so if this is y, then 2.8 minus y, 2.8 minus 0.6875 would also be the distance. So either we move it 0.6875 meters from the NB, or 2.1125 meters from the pivot to balance. So this is the problem of the day. Please, when you are given the question in a statement form, you must think through it very well, else you can easily get it wrong. When you are given the question in statement form, you must look at every statement properly before. Please, if you have any question, ask. Or we move to when you have double pivots. Before we move to double pivots, let me clarify this. Do I clean the board? Hello, do I clean it? All right.
Yes, please.
A plank or board is pivoted, I can indicate the position of our pivots in two different ways. Either the position of pivot is drawn as a knife edge, or I can represent this as just a thread connecting to a support. So the pivot can be this, or it can be connected to, the plank can be connected to a string and then be given a support. As in, you see, when you go to offices where, and then there is a need of them to hang some notices on the ceiling. This is what they do. So it's the same as pivoting something. After all, we just will require a point where turning effects will take place. So it can be pivoted as this or as this. Okay, if it is pivoted with a knife edge, then this edge will produce a reactional force to balance the weight of the bar or of the plank. If it is suspended, or suspended using a string, then the string will produce tension to balance the weight of this body or object. So take note. If it is on a knife edge, there will be a reactional force in the opposite direction, meaning the weight can be here. The weight would actually always follow the line of gravity, so downwards, and then in the opposite direction there will be the reactional force. If it's about string, the weight of this bar would act downwards, and then the string okay, would balance the weight so that the net effect will be 0. All right, so let's look at what happens if we have 2 pivots. How do we solve 2 pivot problem? So I'm going to draw either a uniform first, a uniform plank pivoted at 2 points. So these are 2 pivots. Now, as I said earlier, it being pivoted will produce a reaction at R, and then the reactional force produced by this pivot maybe R1, R2. Now, if we are looking at the weight of this, then using the principle of moment, we can argue that total weights or forces acting downwards must be balanced by total forces acting upwards. So W is equal to R1 plus R2. That's the first principle of moment. If this happens to be the only weight, now if there are some number of weights around, maybe at the end we have this weight F1, at the other end we have this weight F2, and then the instruction is that calculate for one of them. Of course, we will be given the distance. Maybe this is X distance from pivot P, Q. The pivot's 9 edges are labeled P and Q. So it means from this pivot Q to this force, the distance is X. Then from F2 to this pivot, the distance is Y. Okay. Then this weight acts at the center. We can be given the entire. So in situations like this, all that I'm saying is that we use the principle of moment, okay, to solving problems around this. But the difference is that when you have 2 pivots, you always assume that one pivot is not in existence. Okay, so to solve this, I'll give a real question. But in applying the second law, which is sum of clockwise movements must be equal to the sum of anti-clockwise movements. If you have 2 pivots, you always take the turning effect around one of them and assume one is in existence. So taking moments around, maybe I'm choosing P. It means that I'm assuming I'm only taking turning effect around this and assuming this is not there. Because this is what I've picked on. If you want to take moments around Q, then you assume this is not there. But if you are assuming one does not exist, the question is that it doesn't go with the reaction. The reaction produced by it must stay for balancing. Okay, so in real problem solving or application of this, you always take moment around one of them. When you finish, you take moment around the other. But in eliminating one, it doesn't vanish with the reaction. Please, any question before I bring in a real problem so we can try? Any question? Okay, let me pick a question. I'm picking a question under this so that we look at how we can use this concept to solve. Yes, I'm coming. Okay, so we have a uniform bar like this, pivoted at points X and Y. The reactional force produced by this is X. The reactional force produced by the other one is Y. We have masses. We have a mass of 8 grams hanged at the far end. We have, this is 15 grams. And then this is also 10. The perpendicular distance of the 8 grams from pivot X is 1. So from here to here, this is 1 meter. From the pivot X to 15, 2. Then from the 15 to Y, this is 1 meter. Then from the 10 gram to the pivot Y is 2. Now the instruction requires that we find the reaction X and Y. Find the reaction X and Y. So find the reaction X and Y. So if you are done drawing whatever is on the board, let me know so that we solve it. Are you done drawing? Hello, are we done? Hello, can you hear me?
Yes, sir.
Yes, please.
So,
Please, we are not done.
Aria, it's just a sketch. It's just a sketch. So, Aria. Can we start?
Yes, sir.
Yes.
Okay, so we are using the principles of movement. And one, sum of upward moment or forces must be equal to the sum of downward forces. So it means that x plus y must be equal to 8 plus 15 plus 10. Please, let me reiterate this. You can choose to convert this to weights or use masses. It doesn't change anything. Okay, so I saw some of you because you want to moment is force times perpendicular distance, you are converting the masses into forces. Please, mass and weight are related. The only difference between them is acceleration due to gravity. So I can use masses without converting them to anything. And if you want to convert to, nobody would also stop you. So x plus y is equal to, this is equal to 33,
Yes, please.
equation 1. Now, I can take moments around any of them. Maybe P and Q. And actually, I will also actually take the moment around both of them. Then when I finish, use this to be sure whether my values are correct. So taking moments around P, meaning I am starting with P. Taking moment around P means that it's as if this is not there. Q does not exist. However, it doesn't go with its reaction. Y is still there. So all that I'm saying is that turning effects is taken around P. So if turning effect is taken around P, we identify clockwise and anti-clockwise movements. 8 gram, will it give us clockwise or anti-clockwise? The 8 gram mass or weight, will it be clockwise or anti-clockwise? Quick response, quick response. Oh,
Please anti-clockwise.
let's be quick in our response. So A, what about the 15? What about the 15 gram? What about the 15? Cardinal, Julian, and Co. Give me quick response. 15.
Clockwise.
10.
Please clockwise.
Clockwise.
Why? Will Y be clockwise or
Anti-clockwise.
Anti-clockwise.
so it will turn this, so you go A. What about X?
Clockwise.
Open your eyes. What about X?
0.
Anti-clockwise.
0. 0 because the force X is on the pivot. So there will be no perpendicular distance. Okay. So let's sum up all clockwise movements. Summation of clockwise movements. So clockwise movement, we have 15 by, what is the perpendicular distance from the pivot? The 15 gram. What is its perpendicular distance from the pivot? Hello?
2 meters.
2. Then the other clockwise 10 gram. What is its perpendicular distance from the pivot?
5.
5. So we have 30 plus 50, giving us 80. 80 gram meter. If you are converting, you are not wrong, but it's not necessary. So let's look at the sum of anti-clockwise moment. Oh, okay. So the anti-clockwise moment, 8 gram is giving us anti-clockwise. What is its perpendicular distance from the pivot?
1.
1.
1.
Then y is also giving us anti-clockwise. What is its perpendicular distance from the pivot?
So we can see
1.
What is y's perpendicular distance from the pivot?
3 meters.
So y is here. The distance from the pivot, 1 plus 2, 3. So we have 8 plus 3y. Okay. Then you equate for equilibrium. Sum of clockwise must be equal to sum of anti-clockwise. So 8 plus 3y must be equal to 80. Therefore, 3y is equal to 80 minus 8, which is 72. Y is equal to 72 over 3. What is 72 divided by 3?
24.
24.
That is 24 gram. If you want to express this in weight, this is simply 24 grams. So it will be equal to times 0.01 Newton. And you are good to go. But you can because you can always do it, it's not necessary. Okay. So why we found y. Once we have y, we can use equation 1 to determine x. So x will be equal to 33 minus y. 33 minus 24. And we have, I think, 9. But there's another way to go around this. Instead of finding one and then using equation 1 to determine the other, we can use this as a test. Rather, we won't touch equation 1, but we'll use it as a test. And that is, we will take, you see, earlier we took moment around P. We are going to bring Q back and take moment around Q and eliminate P instead. So Q is back, but we take moment around Q, meaning we assume P does not exist. So this time we are taking moment around Q. Earlier we have Y. Y is 24. Let's write it somewhere. So we clear this because we are this time taking moment around the other letter. So when you take moment around Q, I'm clearing the. This time we are taking moment around Q. So we identify clockwise and anti-clockwise. 8 gram will still give us anti-clockwise, 15 anti-clockwise, then 10 clockwise. Then don't forget this will be 0. But this time we'll have X also giving us clockwise movement. Just as we did for when it was P. So you take sum of clockwise, take the sum of anti-clockwise. So let's take summation clockwise movement. I'm using a symbol for clockwise. So clockwise movement, we have 10 times the perpendicular distance. This time is 2 plus X times the perpendicular distance. What is the perpendicular distance of X from the pivot Q? What's the perpendicular distance of X from the pivot Q?
3.
That's 3. So that does it for clockwise movement. So we have 20 plus 3x. Then summation anti-clockwise. Anti-clockwise movement. Anti-clockwise, we have 8 and 15. So 8 gram times the perpendicular distance. What is the perpendicular distance of the 8 gram mass from the pivot?
4 meters.
That is 4. 1 plus 2 plus 1. So 4. Then 15. So 15 times 1. When we sum this up, we have 32 plus 15. And this is giving us 32 plus 15 is giving us 47. So sum of clockwise movements equals sum of anti-clockwise movements. So we equate them. 20x plus 3, 20 plus 3x is equal to 47. So we have 3x equal to 27. X is equal to 9 gram. So you see, we now have X, we have Y. So we use equation 1 to test whether our values are correct. Look at equation 1. Equation 1, we are saying that X plus Y is equal to 33. Sum of upward and downward movement, okay, must be equal. So X plus Y is equal to 33. We have X to be 9. So is it, we prove that 9, we test whether 9 plus the 24 would be equal to 33. If 9 plus that is equal to 33, then it means that whatever we had for X and Y are correct. So even though we can use, when you get 1, you can use the equation 1 to find the other, but you can also take the moment around the other pivot and use equation 1 as a proof or test of the accuracy of your values. Please, is that okay?
Yes, sir.
All right. A question for you to try. A question for you alone. I'm reading. I think there's a kind of question you have to create a diagram out of it. Okay. Hold on, I'm coming. So a uniform rod AB, of length 2 meter and mass 4 kilogram is supported at its ends using a knife edge. A uniform rod AB of length 2 meter and mass 4 kilogram is supported at its ends with 2 pivots. A mass of 6 kilogram.
So please come again.
A uniform rod AB of length 2 meter and mass 4 kilogram is supported at its ends with a pivot. Is supported at its ends with a pivot. Millicent, mute yourself. Millie. A mass of 6 kilogram is placed at a distance x meter from A. And the reaction at B is 3 times the reaction at A. I repeat that part. A mass of 6 kilogram is placed at a distance x meter from A. And the reaction at B is 3 times the reaction at A. Find the distance x and the reaction at the supports. Find the distance x and the reaction at the supports. I take it again. A uniform rod AB of length 2 meter and mass 4 kilogram is supported at its ends with a pivot. So there are 2 pivots at the ends. A mass of 6 kilogram is placed at a distance x meter from A. And the reaction at B is 3 times the reaction at A. Find the distance x and the reaction at the supports. So we have the diagram as two reactions or two pivots at the ends. This is A and B with reactions at both ends. You are given the length of the rod, and then you are told that it's a uniform beam, so its mass is given. Then we have a weight which is placed x distance from A. The mass is given, I think 6. So 6, a mass of 6 kilograms is placed at a distance x from A. So 6, and then its weight. Its mass is also given. It's a uniform beam, so you know. So the question is that find the reaction at both ends and then the distance x. So let me give you about 10 minutes to engage your thoughts. Let me see what you can produce out of the question whilst I upload attendance. Okay, so this is the problem of the day. Think through it and let's see. So all that I'm saying is that from the end to where the mass is will be 1 meter from both ends. Then a mass of
That's the solution is right.
Please, your camera.
Physics. Oh, he has it.
Can I continue?
Yes, please.
Okay, so a mass of 6 kilograms is placed at a distance x from A. This is A. A mass of 6 kilograms is placed at a distance x from A. This distance is unknown. So I'm assuming that from the end to where this mass of 6 kilograms is, let the distance be x. Let the distance be x meter. Okay. Then, and the reaction at B is 3 times the reaction at A. I'm told the reaction at B is equal to 3 times the reaction at A. So all that I'm saying that if the reaction at A is maybe A, and the reaction here is B, I'm told that the reaction at B is 3 times the reaction at A. So this is A. The reaction at over here is A, and the reaction at this point is 3A. Please, is it understood?
Yes, please.
Yes, sir.
So you just take your time to go through the question, read it, and then put your idea on paper, bit by bit. 2 meter uniform plank. Okay. It is uniform. So its mass will act at the center. So this is the mass. The distance between the support A or the support or the pivot. This is a 2 meter. Okay. A mass of 6 kilograms is placed x meter from A. From A. Then reaction at B is 3 times the reaction at A. So let's take our moments. Let's go through the laws. It means the first law, sum of upward forces must be equal to the sum of downward forces. So A plus 3A must be equal to 6 plus 4. This is 10. This is 4A. Therefore, A is equal to 10 on 4. 5 on 2. 5 on 2 is 2.5 kilogram. So if A is 2.5, then B, the reaction at B is 3 times 2.5. We are good to go. Please, are we okay?
Yes, please.
Then
Yes, sir.
you take the moment around one of them. Okay. You take the moment around one of them. It can be around A or B. So taking moment around B, taking moment around B, it means A does not exist, but it doesn't go with the reaction there. So take clockwise moment. This will give you clockwise. This will give us anti-clockwise. This will also give us anti-clockwise. The turning effect by this is 0. So clockwise moment, you have A by the perpendicular distance, which is 2. This must be equal to the sum of anti-clockwise moments, 6 by, what is the perpendicular distance of 6 kilogram from B, from the pivot? What will be the perpendicular distance? Yes, class. What will be the perpendicular distance of this from the pivot? Oh, who is sharing this with that?
2 minus x.
2 minus x. This is x. The whole bar is 2. So 2 minus x plus 4 times the perpendicular distance 1. Knowing A, you can find x. So help me find x. Do it and then tell me whatever you get for x. What have we had for x? What have we had for x? Mamiya Eva. Julian.
$1.833.
Give it to me in fraction.
11/6.
11/6.
Yes, the answer is 11/6. So, you see, I beg you, when a question is given to you, take your time to analyze it. It's not really so difficult. It's not so difficult, but it's about how you would analyze it. Okay, let's take this question. Let's take another question. A horizontal uniform rod. A horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires.
So please say the masses.
Okay, I take it again. A horizontal uniform rod of mass 5 kilogram, 5 kg, and length 2 meter is supported at each end by wires. Is supported at each end by wires suspended from a ceiling. A horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires suspended from a ceiling. If a mass of 4 kilogram, if a mass of 4 kilogram is placed 0.4 meter from one end, if a mass of 4 kilogram is placed 0.4 meter from one end, find the tensions in the wires. If a mass of 4 kilogram is placed 0.4 meter from one end, find the tensions in the wires. This is just similar to 2 pivoted, but these are wires. So all that is being said is that we have a uniform bar, then both ends are suspended to a ceiling by wires. So one wire at the end connecting to the ceiling, another one at the end connecting to the ceiling. I told you that when it's about wires, there are tensions T1, T2 within the wires, just like the pivots. You are given, it's a uniform bar. So each weight or mass would act at the center. Then you are also told that there is a mass which is placed 0.4 meter from one end. I think 6 kilogram or something from one end. Don't forget here you can choose, place this at any chosen end. Okay, 0.4 from one end. So it can be this end, from this end, or from this end. The choice is yours. Determine the tension in the string. Please go through this and make me proud, so I can also be proud of you. Start work. And you must get this right. In fact, you must get this. We have solved quite good examples. So apply the same idea. Let's get this. So you are determining the tensions in the string. The tensions are represented by T1 and T2. So I'm waiting for you. I think in 5 minutes time, we should be able to handle this. Maximum 5 minutes. So I'm waiting for